Here's a video on even and odd functions. The first slide just talks about testing for an even and odd function. Here's what happens. You're going to substitute into the function a negative in for every x. And if you get your original function back, it's considered even. If you do that same thing again, you substitute a negative into the function, wherever there's an x, and you get the original function back with a negative, then it's considered odd. Here are a couple examples of an even and an odd function. If you have an even function, you're going to have symmetry about the y-axis. So here's your y-axis, and you're going to have symmetry. So if you look at this side, is the same as the other side on the y-axis. If you have an odd function, after you test for it, you're going to be symmetric about the origin. So your origin is 0, 0, so everything from the 0, 0 to the other side would be the same. So let's go ahead and look at a couple examples here. The examples that I have on the left, in this case there's just one of them. Here is a parabola. If I drop the line of symmetry here about the y equals x, it'll be symmetric. Here is my cubic function, or snake. So it'll be considered an example of a odd function. If you flip it, you would get the same ordered pair back about the origin. And then a couple more examples of odd functions. All right, what we're going to do next is we're going to go ahead and test for it. So we're going to use this box that's already on our first slide. So let's test to see if this first function a is a even function or an odd. So we're going to plug in negative x into the function. So we'll substitute negative x again, and we'll simplify it. So when we simplify, negative x to the 6th power becomes an odd, or a positive. And then negative 2, negative x times negative x is x squared. And what happens is when we look at the original function and what we just got, they're exactly the same. So this means that this is an even function. All right, let's go down to example B. We're going to test for it again, so we'll plug in our negative into the function. So we simplify that, negative x times negative x times negative x is negative x cubed minus 5. Well, we didn't get our original function back, so let's take out a negative 1. We didn't get our original function back with a negative, so this would be considered a neither. All right, our last example, C. We'll plug a negative into the function. We'll simplify it. Negative x times negative x times negative x is negative x cubed. Negative x times negative x is a positive x. Well, we didn't get our original function back, but let's now pull out a negative. What we're left with is x cubed minus x. If we look at this piece and this piece are exactly the same, so that's the original piece of the function, with a negative. So if we scroll back up here, this is what we have, so it is an odd function. So it is symmetric about the origin.